Again, that is page 31 and 32 in your books, and it's questions 1, 4, just A, B, and C. We're not going to do D until class later. All right. So we've been learning in class about 3 major concepts: the slope, the midpoint, and the distance. Those of you guys that want to use the slope formula and the distance formula, you're more than welcome to. I'll review what that is. x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2 would be the midpoint formula, and the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. So if you would like to use the distance formula and the midpoint formula, please do so. Okay, I'm going to show these today by graphing them. I'm going to model A and then have you guys do B on your own. Okay. So the first thing I'm going to do is I'm going to actually plot these 2 points, A and B. So -4 and then up to, down to -10. So there's where the coordinate A would be, and then I'm also going to do the second coordinate B. 1, 2, 3, 4, 5, 6, 7, 8, and up to 6. 1, 2, 3, 4, 5, 6. There it is. And there's my B. Okay, so what I'm going to actually do is I'm going to grab a random straight edge and connect the 2 points. And there is the segment that I'm going to be working with right now. Okay, so the first thing we do is we need to find the slope. So if you remember, slope is rise over run. So in this case, that's exactly what we're going to do. We're going to rise up all the way until we get to B, and then we're going to run over to B. Okay, so all I got to do is essentially count how many boxes up it is, and then how many boxes to the right it is. Right? So if you count all of these boxes, you're going to get 16. Right? And if you count all of these boxes over here, you're going to get 12. So that means my slope would be 16 over 12. Okay? And I am going to reduce it. Okay? So if I reduce both of them are divisible by 4. So if I divide that by 4, I'm going to get 4. And if I divide that by 4, I'm going to get 3. Okay, so there's the slope in reduced form. All right, now how was that connected to midpoint? Well, if you remember today's lesson, midpoint meant the middle. Right? So if the full rise is 16, then the middle of that would only be 8. So instead of counting 16 up, I'm going to count 8 up. 1, 2, 3, 4, 5, 6, 7, 8. So from here to here is 8, and then I'm going to go over until I get to the line, and then that is where I would find my midpoint. Okay. So then I would just give the coordinates of that point, which is 1, and then down 1, 2 to -3. So my midpoint, if you did it by the midpoint formula, you should get the same thing. You should get 1, -3. Now, with the distance, well, we're going to use the same graph and pretty much the same numbers. Now, remember, when we were using the distance formula, it's a different version of the Pythagorean theorem. You're still going to be doing the same exact thing. Okay, so I'm going to call this side my A, so I'm going to do 16 squared plus my run of 12 squared. And that's going to give me my C squared. So I'm going to go ahead and grab my calculator. I'm going to do 16 squared plus 12 squared, all in the calculator at the same time. I get 400. So remember, that number is not your real distance right now. That's what C squared is. So again, at the end, you have to remember that you're going to take the square root of 400, okay, which is the symbol here. Okay. On the graphing calculator is located right below above the square root, the square sign. So I'm going to do second square root of 400, and I get 20. So that is the distance of AB. Okay. So with that, you guys should be able to model and do the similar to question B. Right. Same procedure. if you need to, rewind the video. All right, I also assigned you guys number 4, so I'm going to flip over to number 4. And number 4 is essentially the same thing that you just got done doing. So they ask you to find the midpoint of AB. So I find it easier graphically. If you want to use the midpoint formula, please go right ahead. Okay, so graphically, if I count, I'm going to count this because it's a little bit easier. This is 2. And then midpoint would be halfway. So here's my halfway point. So I'm going to follow this up until I can get to the line. And it's going to cross here. Let me just double check myself. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So as you saw, the same distance on both pieces. So there's my midpoint of AB. And it says to label that D. So I'm going to label this D. And I'm going to allow you guys to fill in what the actual coordinates are. I'm going to find the midpoint of AC in a similar fashion. Okay, I'm going to go over. And then I'm going to go down. And then again, midpoint means middle. So we can count the whole entire length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see the whole entire length from here to here is 10, so I'm going to count halfway. 1, 2, 3, 4, 5, and then go down. Here is where my midpoint is. I'm going to label that one, as they told me at the instructions, with the E. Okay, so then I'm going to leave you guys to figure out what the actual coordinates are. Okay. Now for here it says to draw segment DE. So that means connect from D to E. All right, find the slope of DE. All right, I'm going to count the up, I'm going to count the over. It's up 1, 2, 3, so that's a rise of 3. And it's a run of 1, 2, 3, 4. A run of 4. Okay, so since I created a right triangle to find the slope here, that's very similar to what we've been doing for the distance slash length. This essentially would be my A, and this would be my B of the Pythagorean theorem. So I'll start it. 3 squared plus 4 squared is going to equal C squared. And then I'll leave you guys to find the length of DE. You do a similar fashion to be able to find the slope of BC, which is the bottom part of the triangle, and then a similar fashion to find the length of BC. Okay, so I'm going to leave you guys at there to be able to find the rest of that. If you have any questions, please ask in class.